Okay,
Thank
my
you.
name is Jan Kaspar. I'm from Enecolab, and our work concerns the thermochemical treatment of dust and fines. Why this is important within our project? The point is that within our project, we effectively find when we start from the wind from here, we find that there is a lot of production of dust and fines in every part of our processing, which means that about 50%, up to 50% of the material, of the starting material, is essentially material which is difficult to trade and which needs, of course, to some needs to be to attain some valorization. So our mission in this project was to find a way to minimize the dust and fines production, because this is essentially one of the most important problems in this processing, and then cooperating its capture. And the third point is the one which I'll be talking today, which is the waste valorization in terms of energy. So let me go with what is there now. Normally, as already has been told, is that dust and fines presently are either used in the cement factories as well. For example, in France, it is quite widespread use, or landfill, which of course is undesirable. The alternative was we have been talking, we have just heard about the catalysis or some thermochemical processes. Essentially, those thermochemical processes so far discussed have been best processes, whereas in our case, we work on a continuous process. So essentially what we do in our job is to have some waste. Of course, the process is tuned in this project towards our dust and fines, but could be possibly any kind of waste which has some significant part of organic waste portion. We pre-treat and move it into a reactor, which is a pyrolysis reactor. And eventually there is a post-treatment. The main product which are interesting in is the piston gas. The reason is that production of oils or whatsoever normally leads to complex mixtures, which maybe for application need to be separated or so. Whereas syngas is a quite effective energy carrier, and this is what we want to do. The second aspect is that during this process we obtain inactivization, so we can have even a toxic waste, which may end up possibly with a not toxic waste, which can be discharged. So what essentially we do is, as I said, is a high temperature pyrolysis. We can work in this range of temperature between 800 and 1,000 degrees. And the main product which we want to produce is the syngas, which eventually can be purified and used as a syngas, or even simply by burning and using it for heating or for energy, for electricity generation. The residual solid, of course, might be post-treated because of normally we have gases, char, liquids, and inorganics, which are produced by a pyrolysis process. And of course, under our conditions, what we want to minimize is the liquid production in char, and of course, possibly the char as well. So these are the objectives of our project, in the sense that what we are looking out is to obtain energy from here, to obtain as an energy carrier. So clearly, within this project, we have quite a number of problems and quite a number of variables which has to be under investigation, and effectively we are just optimizing our process. And because at first we have to resolve many problems which are due, for example, to transport of the materials, because it's the apparent density is sometimes very low, which means that you need an effective transport within the continuous reactor. Find the appropriate conditions, because the proportion of fibers and resins is quite variable. As I haven't shown before, it may be between 30 to 70%, so very large conditions. And of course, the amount of gas produced is strongly dependent on this proportion here. Clearly, the kind of resin also impacts on the calorific value, and there is also some process parameters which we are optimizing. What you see here is a table which reports some examples of a laboratory scale which can process a kilogram of SOS, and an industrial scale of our reactor, which I will show you in a next presentation. And you can see that essentially we have a quite significant part of the CO2, because this is arising from the oxygen which is contained in the starting polymers, of course, and the resins, but reasonably appreciable CO is calorific value which is obtained in this project. If I go show you just the reactor is quite small. This is a reactor which is capable of treating up to 20 kilograms per hour of material. These materials can be made modular. These reactors can be made modular, and so we, for example, are working on parallel projects where 10 of these reactors are used in parallel and can process tons and tons of materials per day. And essentially, what is important in all the discussion is that we have at this point a gasification efficiency which is about 0.2, 0.3 cubic meters per kilogram of material. But the important thing, I think, is that we obtain a significantly higher amount of energy in terms of from the gases that are produced in the product. We don't consider the energy contents of the char, which is coming clearly together outside from the reactor, which can be then treated and under oxidative conditions and generated further heat, which is quite high. But these values, to be honest, are quite low in this case, because we have been using materials which has a relatively low carbon contain. When we start from some other materials, we can obtain an energy which is about even twice that of that employed for our treating. So, coming to the summary, I think that we have shown that this project, this pyrolysis reaction, is able to convert these materials and obtain syngas, which is a useful energy carrier. Preliminary results, as I said, not optimistic one, shows clearly that the amount of energy recovered exceeds that used in the high temperature treated. And essentially, what is the idea of the JOS project? It is designed to be integrated within an industrial process. This is an important aspect, because as long as you move the waste of your product within the project, it's not classified as waste. The waste will be the final product of our product, which, however, we can inertize even toxic materials. And most importantly, we recover and have an exceeding value of the energy content. So I think wish you to thank you for your attention. And of course, we are open for questions. And thank you very much.